Hi everybody, this is Teacher Yong Lam and welcome to the explanation video for the common mistakes in our P3 HAL Math Mock Test 5. Right, so let's start off by showing you again, right, our overall statistics for these questions. Now, I realize that the average accuracy rate for this particular paper is slightly lower, right, with some questions that are lower than 50% accuracy rate, right? You can refer to those that I have marked in red. So I will be going through these questions, right? And I noticed that there are quite some word problems as well, right? So hopefully through this explanation, you could have a better understanding, right, for these commonly mistaken questions. All right. So without further ado, let's get started with our first of two multiple choice questions, right? It is question 17, a fraction word problem. Now let's read the question. Michelle baked a cake. All right. She gave away 1 over 8 of the cake and ate 1 over 7 of the remaining cake. Now, what fraction of the original cake did she have left over? Right? We want to express our answer in the simplest form. So in this question, you realize that it's a fraction word problem with two fractions. So whenever you see two fractions, the first thing that you have to make sure is whether these two fractions are talking about the same total or not. Right, so let's read the question again. The first fraction is she gave away 1 over 8 of the cake. Okay, so that means the first fraction is about the entire cake, right? It's taken from the entire cake. The second fraction, she ate 1 over 7 of the remaining cake. So are these two fractions talking about the same total? Are they taken from the same total? The answer is no, right? Because 1 over 8 is taken from the entire total, correct? But then the next fraction, 1 over 7, is of the remaining cake, right? So it's taken from the remaining, not from the entire total. Now, if your two fractions are taken one after another and not of the entire total, please do not rush and change them to a common denominator, right? Instead, you try to draw them out one by one. So let's start off by drawing a bar model, right? So let's draw a bar model, right? A long, long bar. Okay, so let's say this is representing the entire cake, right? This is the total cake. And we start from the first fraction. Which fraction talks about the entire total? It is your 1 over 8 of the cake, right? So it's 1 over 8 of the total, which means to select this fraction, I need to divide this bar into 8 equal parts. So let's do that, right? We split into 2 first, then I split into 4, okay? And then every 4, I split into 2, right? So here you can get roughly 8 equal parts. Now, among these 8 equal parts, teacher Yonglam takes 1 over 8 of the cake and give it away. All right, so this is the fraction that is given away. Now, this is your 1 over 8, right? Among the 8 units, 1 unit is given away. So now we focus on finding the remaining. Okay, so where is the remaining? Teacher Yonglam's advice is to draw a dotted line to separate what is already given away and what is remaining. So actually the remaining is this part, right? Which has 1, 2, 3, 4, 5, 6, 7. 7 units, right? This is the remaining. Now, among this remaining, Michelle ate 1 over 7 of the remaining cake, right? So among these 7 units in total, she ate 1 unit. Just nice, right? 1 out of 7. We have 7 units. 1 out of it is eaten, right? She ate it, right? And the remaining is what is left over, right? The bracket is a bit big, a bit long. Let me draw again, right? This is the part that is left over. Okay, so now that we have drawn the model, we can look back at the question. What fraction is she asking, right? It's asking for the fraction of the original cake, right? So original cake, that means the entire cake at first. At first, the entire cake has 8 units. The leftover portion is 6 units, right? So then the portion that is left will be 6 over 8, which is equal to, right? Because remember, I want the simplest form. So can I make the denominator and the numerator smaller? Yes, I can, right? I can just divide the top and the bottom by 2 to get 3 over 4, right? So with that, the answer is D. So here there are two track points. Number one, are the two fractions referring to the same total or not? If they are not, right, consider them one by one, right? First the entire total and then focus on the remaining. Second, what fraction are they asking about, right? It's asking the fraction of the original cake, right? So you compare it with the original total, right? So everything in the question could hide traps. So be very careful when you are reading the question. Now that's it for question 17. Let's move on to our next question, right? Which is a calendar problem, right? I think this is our first calendar problem across all the mock tests. So let's look at this carefully. Benny's birthday is on September 1st, 2007. Given that June 1st of that year was a Friday, right? So we already know June 1st of 2007 is a Friday. Right, June 1st of 2007 is a Friday. Can you find what day of the week did Benny's birthday fall on? So I am finding, right, what is the day of the week for September 1st, 2007. Right, this is a common calendar problem that could appear in your MCQ section, right? You need to find out what is the day of the week for a certain date, given that for another date. Okay, and luckily this question gave us the day of a week for a day in the past, right? June 1st. And we want to work towards the future to find, right, September 1st. What day of the week is it? Right. Usually when we see these sort of problems, right, there are two things you need to do. Number one, you need to count how many days later, right? Compared to our starting date of June 1, right? How many days later will it be? September 1. Okay, how do we do that? Now, here's a little trick to do this, right? We will use a arrow diagram, right? It's like a flow chart. Now, how does this work? Let's start off with a little warm-up question. Now, from June 1st to June 5th, let's say, right? How many days later will it be? June 1st to June 5th will be June 1st, then the next day, June 2nd, June 3rd, June 4th, June 5th, right? It will be 4 days later. So I can say plus 4 to represent 4 days later. Okay, now let's change the question, right? Let's say I'm going to June 13, right? How many days later? Now you can count yourself and you realize that it will be 12 days later. Right. Now, what do you notice? You notice that in this warm-up case, my starting date and the ending date are both from the same month, right? And the date 1 to 13, to find out how many days later, you will realize that the number of days later is simply 13 minus 1, right? So instead of considering 1, 2, 3, 4, 5, one by one, maybe I can just go on to the end of the month, right? The last day of June. How many days are there in June? There are 30 days. So from June 1 to June 30, there are how many days later, right? How many days later would it be? 30 minus 1, there are 29 days. All right. Now, I already reached June 30. Let's go on to the next date, right? Remember, we want to reach September at the end. So from June 30 to the next date, which is the first date of the next month, July 1st. That will be 1 day later. All right. Now, what do you notice? From June 1 to July 1, you have to go through 29 days later and another 1 day later. That will be 30 days later. Right. Now we can do the same thing and let's see if you can observe a pattern or not. Right. From July 1st, I will continue to move on to the end of July, right? Which, July has how many days? 31 days. So we go to July 31st. That's how many days later? 31 minus 1 is 30 days, right? So you plus 30. Then you move on to the next month, which is August, right? Then let's look at August 1. From July 1 to August 1, right? You go through 30 days later, but you need an extra day later to enter into the month of August. So in total, from July 1 to August 1, you will realize you need 31 days later. All right. Now at this point, let's look at a pattern, right? From June 1st to July 1st, you need 30 days later. How many days are there in June? 30. Right. From July 1st to August 1st, it's 31 days later. And 31, just nice. It is the number of days in July. Right. So this is a shortcut, right, to find out how many days later. to go from a date in a certain month to the same date in the next month. All right. Now, we want to go to September 1st, right? That means from August 1st, I need to continue to September 1st. How many days later is that? Remember, we just need to look at how many days are there in the month of August. 31 days. So this time I will plus 31. All right. Now, in that case, this is the long one, but I can simplify this into this specific flowchart, right? So you realize from June 1st to September 1st, I have to go through 30 days later, another 31 days later, another 31 days later. How many days later is that in total? That will be 30 plus 31 plus 31 equals 92 days later. That means from June 1st, which is a Friday, right? I need to go through 92 days later to reach September 1st. Now, this is the first step. How many days later? Now we need to move on to find out, right, the day of the week, right? 92 days later, what day of the week is it? Do you need to list out one by one, right? Saturday, Sunday, Monday, Tuesday, etc. You don't need to. Because a week has 7 days and it will cycle again and again. Right? So you can treat every how many days as a full group? 1 week has 7 days. So treat 7 days, one full week as a group. Every 7 days later, right? We will go to the same day of the week. Friday, 7 days later is a Friday. Friday, another 7 days later will be another Friday. Every 7 days later, I go back to the same day of the week. So, since it's sort of like a cyclic problem, instead of considering all the 92 days later, let's just find out how many full weeks and how many extra days later are there. So you just need to do 92 divided by 7, which will give you 13 remainder 1. Now, 13 here means 13 full weeks later. 13 full weeks later, the day of the week will not change. The key lies in the remainder 1, which means 1 extra day later. So we only need to consider this 1 day later. So from a Friday, 1 day later, what day of the week will it be? That's right, it's a Saturday. So with that, we have gotten our answer. It is A, right? September 1st is a Saturday. Okay, and yeah, that is how you do the calendar problem here. Now that we are done with our multiple choice questions, right? The next question, let me give you a bit of suspense. What problem is it? The next question is actually an interval problem. Right, let's take a look at this question. Teacher Vera had a wooden rod shown below. Now it takes her 18 seconds to cut the rod into 7 pieces. Right, 18 seconds to cut into 7 pieces. If she wants to cut it into 10 pieces, how many more seconds are needed? Quite some traps over here. Now, this is actually one of the more fundamental interval problems. Let's see how we do this. Right. First of all, I need to give you a review on cutting rod problems. Right. So let's have a little warm up. Let's say I want to cut this rod into 3 pieces. Right. So how many cuts do I need to cut this rod into 3 pieces? Do I need 3 cuts? Now, if I need 3 cuts, let's just cut, right? 1, 2, 3. Okay, how many pieces do we have now? We will have 1, 2, 3, 4. 4 pieces. But I only want 3 pieces. How come 3 cuts doesn't work? How many cuts do I need? So if you need 3 pieces, you actually only need 1, 2. You only need 3 minus 1 equals 2 cuts. Right. Think about your pieces as objects in an interval problem, and every time you cut once, you are creating a gap between 2 pieces. So if you have 3 pieces, you can think of it as 3 objects. So in a row of 3 objects, how many gaps should there be between them? There should be 3 minus 1 equals to 2 gaps, or more officially, 2 intervals. So you actually don't need 3 cuts, right? You only need 2 cuts. You need 2 gaps between the pieces, right? So that's why if I have 3 cuts, right? So you will need 3 cuts to create 4 pieces instead, right? 3 cuts means 3 gaps. That means there should be 4 objects. So now back to the question. The question first says that it takes her 18 seconds to cut the rod into 7 pieces. So if I want to have 7 pieces, how many cuts do I need? I will need 7 minus 1 equals to 6 cuts, right? 7 objects means 6 gaps between them, right? You can even use the picture, right, as a room for your experimentation. Indeed, 6 cuts is enough. 1, 2, 3, 4, 5, 6, 7, 7 pieces. So you need 6 cuts, and every cut will take some time. In total, it takes 18 seconds to produce these 6 cuts. So what is the time for one cut? The time for one cut will be 18 divided by 6 equals to 3 seconds. Every cut will take 3 seconds. This time, right, we found the time for one cut. Let's continue with the question. Right, the question is asking if she wants to cut it into 10 pieces instead, how many more seconds are needed? This time, right, I'm cutting it into 10 pieces, which means I will need 10 minus 1 equals to 9 cuts. 9 such cuts, how long will it take? We already know each cut is 3 seconds, right? So then the time taken for 9 cuts will be 9 times 3 equals 27 seconds in total. In total, if I were to cut it into 10 pieces, I need 27 seconds. But the question is very sneaky, right? Is it really asking for the total time? No, it's asking how many more seconds. How many extra seconds on top of the original 18 do we need? So to find the extra seconds needed, you will just do a round of subtraction, right? 27 in total minus the first 18 seconds that you're already done. That will be 9 seconds extra, right? So your answer is 9 more seconds. Now, alternatively, you can just think, right, from 6 cuts to 9 cuts, how many extra cuts do you need? You will need 9 minus 6, which is 3 more extra cuts. Each cut takes you 3 more seconds, so in total, 9 seconds. That is another way to get the correct answer. All right, and that is it for this interval problem. Now let's move on to the next question, right, which is a comparison and replacement problem. Now let's read the question. By observing the following two scale balances below, calculate the mass of a pear. All right, so it's a pear. We have two fruits over here, right? Two types, pears and bananas. Let's observe each scale and form an equation first. In the first scale balance, you have 3 pears on the left, you have 4 bananas on the right, plus an extra 4 gram. And they are equal, right? The scale is balanced, so we say that it's equal. This is the first equation now, right? You have 3 pears equals to 4 bananas plus 4. Next, on the second scale, you have 2 pears and 2 bananas, and their total mass is 54 grams. Right, so let's repeat the equation. 2 pears plus 2 bananas is 54 grams. Right, so we want to use these two equations to try to form, right, some useful calculations to find the mass of each fruit. Now, how can we do this? There's, of course, a lot of way to manipulate the equations, but I'm going to take a look at the second equation first. Right, you realize that I have 2 pears and 2 bananas. Right, it's as if I have 2 sets, right? 1 pear, 1 banana, another pear, another banana. Right, and 2 such sets have a total mass of 54 grams. So intuitively, you might want to simplify the equation and find out, what if I only have 1 pear and 1 banana? Right, so 2 sets is 54 grams. From this equation, we can get that 1 set, right? 1 pear, 1 banana will be 54 divided by 2 equals to 27 grams. 1 pear and 1 banana is 27 grams in total. Okay, but how can we use this, right, to form an equation with only one type of unknown symbol? Because you see that both equations, right, you are relating the pears and bananas together in each equation. In order to calculate something, you want an equation with only one type of fruit. So how can we do this? So Maybe we can look at the first equation, right? The first equation says that three pears is the same as four bananas plus four. So whenever I have three pears, I can replace it with four bananas plus four. The moment I see three pears, I can replace it with something else. This is useful for this equation, right? If only I can form three pairs. Currently, I only have one pair, right? Because it's only one set. In order to get three pairs, maybe we can consider three sets, right? Which is three pairs plus three bananas. Now, if one set is 27, three sets will just be 27 times 3 equals 81. Three pairs and three bananas is 81. And now, since we have three pairs already, right, we can replace it with another form, four bananas plus four. So let's replace it overall, right? It becomes four bananas plus four. And don't forget the original three bananas. The total is 81. So now let's simplify the equation a bit, right? To find out how many bananas do we have? Four bananas plus another three bananas. Let's write on the right. That will be seven bananas. And don't forget, we have a plus four. That will be equal to 81. Right. So from there, you can find out one banana or seven bananas first, right? Let's go slowly. Seven bananas plus an extra 4 grams is 81 grams. So seven bananas is 81 minus 4 equals 77 grams. Now the bananas are identical, so you can just get one banana is 77 divided by 7 equals 11 grams. Now before you get too excited, we are asking for the mass of a pear, not a banana, right? So in that case, what about a mass of a pear? Which equation would you use to help you? Either of them would work, but we usually work with equations with smaller numbers, right, to prevent calculation errors. For me, I will work with the value of one set. We know one pear and one banana together is 27 grams. So if one banana is 11 grams, then one pear will simply be 27, which is the total set, minus 11, and that will give you 16 grams as your answer. Right? Now, again, this is not the only way to do this, right? As long as you do everything logically and get the same answer, that method definitely works. All right. So this is one of the more challenging comparison and replacement questions. And yeah, hopefully this helps. Let's move on to our next question, which is an excess shortage problem. Now, for my MHA kids, you have already learned it recently, right, in class. Now, let's read the question. Greenville Primary School is organizing a field trip for the pupils. If the seating capacity of each bus is 35 pupils, then 5 pupils will not be able to board the bus. If the seating capacity of each bus is 40 pupils, there will be an extra empty bus. How many pupils are going on the field trip? Now, excess shortage, actually, the essence is you are distributing some items to groups, and there are two ways of distributing them leading to different results. Right. So let's look at this question. Whenever we see an excess shortage problem, we need to think, what are we distributing to whom? Right? What are the groups and what are the items? Okay, what am I distributing to? Those are your items. To whom are you distributing to? Those are the groups. Now, here you can think of it as I am giving pupils to buses. Every bus, either I give 35 or every bus I give 40. So you can think of one group as a bus, and the items are your pupils, right? You are giving pupils to buses. I know it's a bit counterintuitive, right? But you think of it, either you're grouping 35 by 35 or 40 by 40. So the items that you are grouping are your pupils. Now that you're done identifying your groups and items, it's time to list out the two scenarios. Okay? Now, in the first scenario, you are giving each bus 35 pupils. So there are 35 in a group. If every group you give 35, 35, 35, 35, 5 pupils will not be able to board the bus. Now think about it. If you are giving 35 by 35 by 35, at the end, you have 5 pupils without a bus. Does that mean you have too many pupils or not enough pupils? That means you have too many pupils. So it's an excess, right? The excess will be 5. You have 5 extra pupils. 5 pupils too many. So that's the first scenario. It's the easy one, right? Now, let's look at the second scenario. If each bus has 40 pupils, this time you have 40 in a group, 40 in a group, so on and so forth. Right. Now, take note, the number of buses in both cases did not change. Right. It's just ideally you want to give each bus 40 pupils. If you want to give each bus 40 pupils, 40, 40, 40, 40, you realize that there's an extra empty bus. Now, a lot of students, when they see this, they will think, oh, extra. It's an excess. And it's excess one bus, so it's excess one. Now, this is not correct because, right, remember this key point. When we are expressing the excess or shortage, we always express them in terms of the items. Okay, let me repeat. When I am expressing the excess or shortage in our picture, we always express it in terms of the items, which are the pupils. So don't think about whether you have extra buses or not. Think about, is it you have too many pupils or you have not enough pupils? Now, if you have an empty bus, you cannot give students to that bus, right? So that means in reality, this bus has 0. But you wanted to give it 40. Does that mean you have too many students or not enough students? Yeah, you have not enough students. It's a shortage. Now, if one bus is empty, does that mean you're shortage of one student though? No, right? Because this empty bus, you could have given it 40 students. So one empty bus means you need to fill it up with 40 more students. You need 40 more students. It's a shortage of 40, right? So now you express both scenarios. It's time to find out, right, how many buses and how many pupils are there. First, we look at the big difference, which is the difference of the results. Right, from an excess of 5 to a shortage of 40, how many more students am I intending to give to the buses? You see, originally I have 5 extra. I give away the 5 students and I still need to give 40 more, but I just don't have it. So how many more students do I plan to give the buses? That will be 5 plus 40, right? Hint for you. One excess, one shortage. To find the big difference between the results, use addition, right? 5 plus 40 is 45. So it's 45 pupils. Where did these 45 pupils go? It's because I give each bus more pupils, right? Originally 35, now I make it 40, 40, 40. That means each bus will receive how many more pupils? That's right. It's 35 plus 5 is 40, right? Or 40 minus 35. This is what I call the small difference, right? So it's 40 minus 35. Every bus gets 5 more pupils. Now imagine I want to give 45 pupils in total. Every bus get 5. Every bus get 5. Get 5. Get 5. Get 5. Get 5. Right. How many buses can receive students? So that's how many groups we have, right? Every bus get 5. Every bus get 5. So now we need to find our number of groups, which is the number of buses, right? Which is just 45 divided by 5, right? Equals to 9 buses. So if I have 9 buses, how many students do I have? Right, there are 2 cases that I need to check. Right, either the first case where I give 35 each, or the second case where I give 40 each. Use both cases to check if they give you the same number of pupils. Right, so you can either do 9 times 35 in the first case, right? Then excess 5 means you have 5 more students, or 9 times 40, but you have a shortage of 40. Either case will give you 320 pupils, right? So if both cases give you the same number of items, then there's a high likelihood that your answer is correct and you can proceed, right? Your answer is 320 pupils. Okay, so if your 2 answers are not correct, right, 320 and not 320, perhaps either your calculation, there's something wrong, or, right, there is a mistake when you are listing the excesses and shortages. All right. Now that is how you do an excess shortage problem. The key hint, is to express all your excess and shortage in terms of items. All right. With that, let's take a look at our next question, which again is a shortest path question. Now, I've already gone through quite some similar problems in the previous videos, so I'm going to be brief with this, right? Remember, when we have a shortest path problem, we need to identify, number one, what's the directions? Number two, we find the one direction points, right? And settle, right, how many shortest paths are there to reach these one direction points first. Finally, we find the other points layer by layer, level by level, from near the start to the end, right? So let's read the question. Tian Tian needs to travel from her home at point A to her school point B. However, she cannot pass through the store at point C along the way. This is the key point for today, right? She cannot pass through the store at point C along the way. How many different shortest routes are there? Now, to do this question, right, let's follow the instructions. Number one, if she wants to go from A to B using a shortest route, remember I said, right, we always move towards the target. That means I should move upward at every point of time instead of downward. I should move rightwards at any point of time, right, instead of going to the left. We always move towards the goal. Next, right, we try to find the one direction points. This is the starting point, right? I have one way to go from my starting point to my starting point, which is just to not go anywhere, right? Just stand there. But which are the points that I can reach from A by only going through one direction, right? Either you go all the way to the right, right, which will be these points, or you go all the way upwards, which are these points. All right. So now these points, how many ways are there to reach each of these points? There's only one way, right? Because you just go all the way along one direction. So these are all having one shortest path to reach them. Just follow the shortest direction, right? That one direction. Okay. So now that we're done, it's time to go through the other points layer by layer. Okay. So let's start from this level, right? Nothing sus is going on, right? To reach this point, I can come from here and from here. So in total, 1 plus 1, 2 ways. To reach here, I can come from here or from here, 2 plus 1, 3 ways. To come from this point, right? To come to this point, I can come from here or from here, right? 3 plus 1, 4 ways. To reach this point, come from here or come from here, 4 plus 1, 5 ways. Now let's move up another level and you will notice that there is a C over here, right? So let's notice this C a little. The question says she cannot pass through point C. So how many ways are there to go to point C? In that case, I cannot reach that, right? There is no way that I can reach that. So please do not think of coming to C, right, through any road. So you can cross out the roads. And if I have to label it with a number, there is no way to reach point C. No way. So there are actually 0 ways to reach point C. Okay, so this is the special number that you need to take note. Okay, and now let's label the other points, right? So to reach this way, 1 plus 2 is 3. To reach here, 3 plus 3 is 6. Now to reach here, 0. To reach here, I cannot come from C, right? I can't even reach C at the start, which means I can only come, right? Oops, I can only come from the bottom, right? So there are how many ways? 5 ways to reach here. All right, now let's go one level up. Here, 1 plus 3, 4. Here, 4 plus 6, 10. Here, 8. I can only reach from here. I cannot come from C because I shouldn't even be in C to start with. So there's only 10 ways. But this point is safe, right? 10 plus 5, 15. Now let's go another level up. We are almost there. 1 plus 4, 5. Right? 1 plus 4 is 5. This point, 5 plus 10, 15. This point, right? 15 plus 10, 25. And finally, point B, 25 plus 15, 40. So in total, there are 40 shortens half. Okay, now this question, I've introduced you another type of shortest path question where you cannot pass through a point. If you cannot pass through a point, it's pretty simple, right? Just label a 0 at that prohibited point. Okay, now this is a shortest path question, which is a counting related topic. The final question that I want to go through today is also a counting related question. Right, question 50, which is a number splitting question, right? Similar to what we have seen in the previous mock test video. How many three-digit numbers have a digit sum of 5, given that all digits within these numbers formed must be different, right? So I must have 3 different digits that add up to be 5. All right, so teacher Yonglam thinks that this question is different from the previous one. But previously, we are splitting into 3 numbers so that their sum is a certain number. But here, there's an additional condition. It must be 3-digit numbers. So 3-digit numbers, we have to think in terms of the place value, right? So we have the hundreds, tens, and ones. All right, so teacher Yonglam likes to think in terms of the place values. So let's start by considering the first possible place value, hundreds. Now, what could your hundreds digit be? Your hundreds digit could be, right, cannot be 0, You could start from 1, 2, 3, 4, 5, 6. Can it be 6? Cannot, right? Remember, the 3 digits must have a digit sum of 5, right? So I cannot have any digit larger than 5. In fact, do you think I can have a hundreds digit of 5? Cannot, right? Because if my hundreds digit of the number is 5 and I want a digit sum of 5, 5 plus what is 5? The only possible case is 5 plus 0 plus 0. But then it's invalid because I want all digits to be different. Okay, so in that case, my hundreds digit also cannot be 5. So it could either be 1, 2, 3, or 4. All right. So now we just need to look at each case carefully, starting with 100 and something. Now, if my hundreds digit is 1, what must the other 2 digits add up to? It must add up to 4, right? Now, in that case, how many ways can we choose this 3-digit number? 4, the easiest one, you can split into 0 and 4, right? Follow the order. 1, 0, 4. Can, right? Take note, the digits at the back can be 0 because they are not at the highest place anymore. So 104, 113, but there's a repeat, right? So we cannot consider this, right? Get out. 1, 2, 2, and 2 also repeat, cannot. Right? 1, 3, 1, again, your 1 and 1 repeat, get up. And finally, let me move this down, right? 1, 4, 0, aha, right? There's no repeated digits. So there's 2 3-digit numbers currently. Now let's move on to the next case, right? What if we have 200 and something? This time, your 2 digits at the back must add up to 5 minus 2, which is 3, right? So what are our possible choices? 2, 0, 3, possible. 2, 1, 2, 8, there's a repeat, cannot. 2, 2, 1, 2, and 2 repeat. 2, 3, 0, aha, we have another 2 possible 3-digit numbers. Okay, so you see by considering place value by place value and also by considering different choices for the hundreds digit, you can list things out more systematically. Now, the next case is when you have 300 and something, your tens and your ones digit must add up to 2. So you can start with 3, 0, 2, possible, all digits are different. 3, 1, 1, 1 and 1 repeat. 3, 2, 0. Good, right? This is also a possible 3-digit number. And we're done, right? Because my ones digit is 0, I can't go further than that. Now, if my hundreds digit is 4, my tens and ones must add up to 1. There are only 2 possibilities, 401, 410, which are both valid options, right? The 3 digits are different. Now we listed out all the cases. In total, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 such 3-digit numbers, right? And that's how you do this question. Always list in order, consider place value by place value, and pay attention to all the possible conditions, right? Or traps. given by your question. All right, with that, that is all I have for this video. We are about a month away from the actual HAL test, right? Thank you so much for your effort thus far and keep going. All the best. I'll see you in our next video. Okay, thank you so much.